Fred, I think we are ready for your presentation.
Okay, thank you. Hello, everybody. Welcome to the Ozaki Radio Club. My name is Fred Schwarsky. I am W9KEY. I've been a club member at HAM for going on 3 years now. And as the title implies, I'll share with you how I used an aluminum irrigation pipe as an antenna mast. Just a little bit of background trivia, I guess. The agricultural industry in the U.S. is surprisingly large when it comes to irrigation of fields and acreage. Some 56 million acres with 83 million acre feet of water. And you go, well, how much is an acre foot? That's pretty descriptive. You've got 1 acre of land, 1 foot deep, that's 1 acre foot. To put that in perspective, there's probably 2 acre feet of water in an Olympic-sized swimming pool. So we're looking at some 40 million swimming pools full of water. I still can't, even with that explanation, picture exactly how much water that is, but it's a lot. And the question always comes up, well, how do they move all of that water from wherever it is onto the fields or the trees or the crops that they're trying to grow? And over on the right-hand side is one example. This is a moving type irrigation system. It's on wheels. Some of them go in a straight line. Some pivot around the center well point with sprinkler heads on it. The wheels may be driven by the water flow itself, or they may be driven by electric motors. And these, as I understand it, are mostly fixed in place. They're built into a particular field, and you can see those when you're flying over the plain states. You can look down and see green round spots in amongst all the other brown. Probably more common, at least around here, and there is some irrigation used in Wisconsin for potato farmers, particularly that grow in sandy soil. And they'll put in a temporary system. And you can see here a standpipe down at the bottom of this left-hand picture. And the standpipe goes out to a number of risers that have sprinkler heads. And the beauty of this is that it can be moved from time to time. So a farmer can move it from one field to the next as crops rotate or as the growing season progresses. So we're going to be looking at this kind of pipe right here. And just to show you a couple examples, this may be a little challenging for you to see if you're looking on a small screen, so I'll just explain it. But this kind of pipe is available in a variety of diameters and lengths. It can be as small as 2 or 3 inches in diameter. 4 or 6 inches is common. Anywhere from 20 to 30 to 40 feet in different wall thicknesses. Now, what's kind of unique about this is there's a clamping system. And it seems like from what I've seen, there's a variety of different ways of hooking these pipes end to end. Down in the bottom here, you can see just a latch type clamp. Up in the top is a hook type clamp with a sprinkler head on it. The exact clamping system is only important to the people that have a particular kind of pipe, but generally there'd be a gasket in between these two, and you just put the pipes end to end, and it allows them to be moved around as need be. There's also tubes available to make that kind of pipe, and they go from 2 inches all the way up to 1 foot in diameter, and again up to 40 feet. And they're relatively thin wall, 50 thousandths to 72 thousandths, 78 thousandths is the largest. I guess the idea here being that it's still relatively portable. A couple people can pick these up and move them around because they're aluminum. And you go, well, we're hams. We don't buy a lot of new stuff like that necessarily for agriculture, but these pipes are available on the used equipment market. You can get them on eBay. You can find them from agricultural dealers or auction houses around America. And I did just a quick internet search, and this is a fairly common type of picture. Here's a bunch of this pipe laying in a field for sale. I'm sure it was used at one time. Most of them are probably straight. Some of them may not be. And you can see here on the end a clamping system that would be used to hook one end to the other. Here's another example, more used pipe for sale. Probably a little easier to see that this particular one on the right-hand side has a flange on the bottom. So even though they're 4 inch in diameter, they're not necessarily 4 inches on the end. And I guess that will come into play as you try to use it for some type of of a function that it wasn't originally intended to be, like maybe an antenna. Over in the left, these again are the hook type. Down here in the bottom, it looks like these perhaps are quarter turn screw together pipes on the end. So the point is, they're out there for sale. The tough part is, and the part that I faced difficult, is that getting the pipe is probably not prohibitively expensive, except for the transportation of it. I can see that you could easily spend more moving a pipe like this than you would buying it, at least from in a used setting. So why would a ham want a pipe like that? Well, I guess in order to put it in perspective, I can give you a little bit of background. As I mentioned, I'm a relatively new ham. I don't have the luxury of a tower. And even worse, I live about 50 feet down in a valley, not a place that any respected ham would have bought. You normally want to be on a hill. But in this particular case, here's a Google Eye view of my property. There's a county road going along. I'm in the township of Cedarburg, east of Cedarburg. And the view here, just to orientate you momentarily, we're looking north from the road, my house. And there's a couple of important features here that play character roles in my story this evening. The first one is this little rectangular patch in the back is my wife's vegetable garden. It's one of her main hobbies. She's really good at it. She raises some killer tomatoes along with many other vegetables in that garden. It's protected from deer with a 6-foot high fence around it, and it turns out good stuff. To the northern edge of my property, there's a tree here that I chose to use for my first antenna support. And this tree is going to play a pivotal role in tonight's story. So I'm going to, forgive me if this disorients you a little bit, but I'm going to move from the front of the house, front view, and we're going to move around to the backyard. So just bear with me. We fly around to the backyard. Now we're looking south from above my backyard. It's a little bit distorted. Google Earth isn't perfect in this regard, but you can see the garden down here, the edge of the garden down at the bottom, the road again at the top on the south edge of the property, and also some, unfortunately, high voltage power lines that go along the front of my property. So I don't want to put antennas any closer to them than I have to, and I don't use the front yard for that and aesthetic reasons. So when I decided to put in a station, I had nothing to start with, and I early on put in a perimeter ground system. This consists of 9 ground rods that go around the house, 3 of them on the western side, a number along the back. So it covers really 3/4 of the house, plus another rod out here under one of the trees. There's a coax entry panel on the back of the house, as well as my electrical service entrance panel, which is nearby. The first antenna that I put up to get me on HF, this would have been July of 2019, was a fan dipole. And a fan dipole, for those of you that may not be familiar with it, it's a center-fed dipole, but it has multiple wires on it. Each wire is designated for one particular band. So this antenna is designed for 80, 40, 20, and 10 meters. It'll also work on 15, and it's about 82 feet long. So it's hung from the feed point in the center on one tree. It extends out to a pine tree on the south side, and to the support tree by the garden that I mentioned before on the other side. So it's hooked in 3 locations, the center and the 2 edges. The second antenna that I put up, and the reason I wanted another one, let me just back up for a second. This is oriented roughly north and south. So this would be 180 degrees and 0 degrees approximately. I put up a second antenna, and this is just a little over a year old. It was put up in January of 2020, just before the pandemic started. And I tried to use Bill Schnell's rule of antennas. And you try to find a really rotten day to put them up, if it's snowing or raining or cold. And it was about January 3rd, around the time I put this antenna up. And this is an end-fed resonant wire antenna. It's fed at the end over here. It's about 130 feet long. And these antennas are designed for a base frequency, in this case, 80 meters or 75 meters. And it's designed to resonate on the harmonics. So you can run an antenna like this on virtually all of the ham bands. And the beauty of it is it's coax fed, and it's just one single wire that you have to run. No multiple wires, no special feed lines or anything like that. This, over the year and a half or year and a quarter, actually, that it's been up, has become my main antenna. I rely on it. It works great. But like all of my antennas, they're not high enough. They're probably, the first one that you saw was maybe at about 25 feet. This one was at about 30 feet in my backyard. Those people, anyone that might be interested, antennas like this are available. You can also get one that's half the length. It'd be about 65 feet, and it would then go from 40 meters through 10 and cover multiple bands. So they're a pretty neat solution if you have a compromised situation in which you want to just put up a single wire. I liked it so much that I put up a third one. And the third one was specifically designed for 60 and 30 meters. The one I just showed you will work there with a tuner, but it's not native necessarily to 60 and 30 meters. So in this case, this is another end-fed wire antenna, but it's configured, deployed as an inverted L. It goes up about 30 feet into a tree and then 60 feet over to a tree in the front of my house. So as my wife says, we're kind of crisscrossed with wires in the yard at this point. So this is my system, and I was happy with it. And I worked for about a year and a quarter with these antennas set up. But there's a big problem, and somebody may have already guessed it. My wife's the vegetable gardener, and she decided or noticed that my end tree on the north property is a walnut tree, and it's awful close to her garden. And walnut trees and gardens are mortal enemies, and the walnut tree was winning. It was getting bigger. The crown of it was starting to extend over to the garden area, and at that point, it means the roots are extending into the garden area. And last summer, she noticed that the tomato plants on that edge of the garden were not doing well. And she doesn't give me too many proclamations, but I got one. And the proclamation was that walnut tree has got to go because we can't move the garden. The tree's got to go. Well, we'd lived in our house for 38 years at this point, and we had maturing trees, 3 of which were dead or dying. This walnut tree that needed to be cut down, and about 4 other ones that needed to be trimmed. So I contracted with a tree trimming service. Got a date set, but as all of you know that have wire antennas, they've got to come down when the tree trimmers come in, and that's what happened. So at that point, I'm off of HF, and I'm unhappy. So how did I solve this? Well, I got to take you in the Wayback Machine here, back almost exactly 2 years now. We would normally have a spring swap fest coming up in May. And in preparation for the May 2019 swap fest, I was helping Tom, W9IPR, and a group of people load some of the treasures from the equipment shed that we have in preparation to haul it to the fairgrounds for the swap meet. And if you know Tom, it's a great benefit to the Ozaki Radio Club Scholarship Fund. He has sold a lot of material for the scholarship fund. And as I put here, that the days that he's in sales mode, everything is for sale. And if you're helping Tom, you might want to keep your keys handy and in your pocket. You might just sell your car while you're doing it because everything is for sale at this point. Well, I walked in after carrying out a load of treasures. I noticed against the west wall of this shed, up in the rafters, was a long pipe, kind of looked like a flagpole. And I asked Tom, I said, "Hey, what is that thing?" And he said, "It's a pipe, and it could be yours." Well, after a little bit of discussion and thought, it was mine. And so some money changed hands of a reasonably small amount. And I'm glad to benefit the scholarship fund. And I thought, hey, that'll make a great antenna mast someday. But as I was carrying out the next load of stuff, I distinctly remember thinking to myself, how in the world am I going to get that home? I mean, it's a big enough thing. You're not going to just tie it under the roof of your car and drive it home. So I said, well, I'll think about it. I'll come up with some way. I got some friends with car trailers and trucks and things like that. So time passed. Remember, this was 2 years ago. So a year passed and some more time passed. And I thought about it, kept thinking about it, and I never came up with a solution. But at this point, my antenna tree was coming down. Two of my antennas for sure were gonna fall. And the tree wasn't coming back. So I had to solve this problem. And I'll say here, Eureka. Let's move back to last September now. So about a year and a half had gone by since I had purchased this pole. And I thought, well, if you reach this insurmountable problem and if you think about it and wait long enough, you'll finally come up with a solution. That's usually what happens. You'll come up with some solution, except I didn't. I never did come up with a way. I kept thinking about it, and I mentioned it to my wife on more than one occasion, and she finally got kind of tired of listening to me whine about this dumb pipe. And she finally said, well, how much does that thing weigh? And I said, well, I don't know. I mean, two people can easily pick it up. It's not too heavy, but I sure don't want to carry it, very far. And she said, well, why don't we get on our bikes, take some bungee cords and some blankets, strap it onto the bikes and walk the thing home. And I went, that's a really, really good idea. And I should have put it in perspective, because many mechanical problems are solved by my wife with bungee cords and duct tape. And so this was another one of those fine solutions, and it worked. We had to do a little bit of planning though. And the planning is, the particular area is over by the Cedarburg water tower that my antenna pipe was located. And I live down here in the town of Cedarburg, and this is about 3 miles. And I had to figure out, well, even with bikes, how am I going to get this thing back and forth? And I first want to thank Tom, KC9 ONY, for helping twice. Twice he helped me with the logistics of this. We first of all went over to measure the pipe, and I found out I thought it was a 40-foot pipe, but it turned out it was 30 feet. That's fine, and 4 inches in diameter. And there were things living in the pipe at some point, which Tom and I discovered. And so stuff came falling out, mouse nests and so forth, as we tried to move it. But he helped me to measure it, and eventually then to move it out of the shed into an accessible location where I could go get it. So I did a little Google Earthing. I like to use Google Earth for things, as you can see here. And this is the Cedarburg water tower on the western side of Cedarburg. And this is Wauwatosa Road. So the equipment shed is in this area. And I thought, well, it's not a very good place to take a couple of, in fact, it's a bad road to bike on in general on Wauwatosa Road. It's narrow, not much shoulder, 45-mile-an-hour traffic. But once I get an antenna pipe between two bicycles, how am I going to get around the roundabouts and the other things that are in the way? So I went, this isn't looking like a very good solution. So I did a little reconnoitering here, came over, and with Google Earth, I noticed this little area in here, this little park-like grass setting. And I said, I wonder if there's any fences or ditches or mad dogs maybe over here, because maybe I can use that to access one of the city streets rather than Wauwatosa Road. And so as it turns out, this is Poplar Avenue. It's a quiet residential street. And after looking at it, indeed, you can walk right through here. I'm not sure whose land it is. It might be the city's, it might be the homeowner here, but it's just a nice little strip of park-like grass and gets you up into the municipal area up here. So what we decided to do one morning is jump on our bikes, and we came across town early on a Sunday morning to try to minimize any traffic problems that we might have. We parked our bikes up here along a chain link fence on the northern end of the water tower. Went across to the equipment shed, and there's my wife on the front of the pole and me on the back, and we headed up, carrying it by hand, in this case, to go back to the bicycles. So we got along the road, got across the road, had to be a little careful, because when you're hauling something 30 feet across a busy highway, You got to time it just right, but we made it across all right. And the chain link fence here was integral to the story. I don't know how we would have done this without it, because the chain link fence held the bicycles up. You stick the handlebar through the fence and it locks it pretty well in place. And she's got her end tied up here on the front bicycle. I've already got the flag installed, and there I am in the back securing the rest of it. And off we go. And we got down through here, got onto Poplar Avenue, and started our trek home. And I can tell you that if you do something like this on an early Sunday morning, when there are people out for early morning constitutionals, they're out walking their dogs, and they find some very clever things to say to you when you're walking a 30-foot pipe on a couple of bicycles through town. So there we were. We wound our way home. I don't remember the exact path. We were trying to avoid any crowds. The only really tough part probably here was on Washington Avenue in Cedarburg. This is a pretty busy highway, but this time it was getting to be a little later on Sunday morning. The traffic picked up, so we had to time our cross of that in order to not interfere with traffic. And we had a little problem down here. This again is a fairly busy county road. We had to go a couple of blocks and ended up getting moved off into the ditch area a couple times to avoid traffic. But all in all, it went surprisingly smooth. We got some very great comments. Unfortunately, I was so busy, I didn't take a lot of pictures of the trip. We did stop one time because the kickstands wouldn't hold this whole assembly up. So the only time we could stop is when we had at least a 30 or 35-foot building to lean it against. Got a couple of drinks of water along the way. But all in all, it went surprisingly smooth, and it's a great idea. I guess we're not the first ones in the world to figure out you can transport a lot of stuff on a bicycle. They do it other places, but it worked fairly well here, as long as you want to walk. So I got the pipe home. I had a need for it at this point now, and I started thinking, well, how am I going to mount this? Because there's a variety of ways, and there's some requirements that I wanted to put on myself. And I from my work days, I like to write requirements documents. In that, you put in the stuff that you really have to do, and you can put in some things that you'd like to do but aren't necessarily critical. And it kind of formulates in your mind the task at hand. And in this case, I hate rust. I hate rust on stuff. And so I wanted to use all stainless steel or galvanized hardware somehow to mount this thing. And I found out during my research that I was going to use a piece of treated lumber as a support structure. And it turns out that treated lumber chemicals are corrosive and are kind of hard on things like aluminum and steel. And so in the very, very fine print of landscaping timbers and things, they tell you if you're going to use metal, you should use galvanized or stainless steel and not just regular steel or aluminum, because it'll corrode. I don't know how true that is, but it was news to me at the time. And I said, okay, I'll try to adhere to that. I wanted to avoid splitting this pipe. It's not particularly thick. And if ice or rain built up in it, you could easily split it. And in fact, this pipe, I believe, had probably been 40 feet long at some point. I don't know who owned it first. Hopefully somebody on tonight's meeting can give me a little bit more background history on it. But the pipe had clearly been damaged down at the bottom and then repaired. So I suspect it may have been a 40-foot pipe that somebody fixed after it broke at the bottom for some reason. I also wanted to avoid drilling holes in it. It's only 50 thousandths thick, and drilling holes in a thin aluminum tube like that is a place where it would certainly be more prone to kinking if it had any side load on it. You can't really clamp it very tight or you'll crush the tube. And I hate guy wires too. We have a lot of deer walking through our backyard, and I walk through the backyard and I mow things, and I don't want to get hung on a guy wire if I can help it. So I'd like to minimize that. I was hoping that perhaps make this thing tip over. That didn't work exactly right, but I've got a solution for that. And I wanted to be as sensitive as I could. I get along okay with my neighbors, and I don't want to see that ending by putting a nice thing in their view that they get to look at every day. So I was hoping to try to somehow handle the aesthetic part of it. And lastly, I'm looking for a 40-foot pipe because no ham is ever satisfied. I don't care. You can have a 100-foot tower and you probably want a 120-footer. And in this case, I've got a 30-foot pipe and I'd sure like to have a 40-footer. So I wanted to have some flexible mounting system to where if I find a 40-foot pipe, I can substitute it easily. So as I mentioned earlier, I decided to come up and mount it on a piece of landscaping timber on a post that I put into the ground. And some of these were hard to find during COVID times. Menards didn't have any of the size that I wanted, but I did find it at Home Depot. This is the current ad from Home Depot on it. So it's a 6x6 by 10-foot long ground contact treated pressure treated timber. So it's designed. It should last a long time in the ground, certainly longer than I need it to be there. And I think it'll provide some support. So again, on a Sunday night, to try to minimize contact with any human beings during COVID, I headed over to Home Depot. I cleaned out my wife's van enough to load a 10-foot board into it, and I went over there. But the one thing, it's probably in someplace in the fine print of the spec sheet, these things are really heavy. And this particular piece of timber, as I went over to try to sort through the pile that they had, I realized it's somewhere between 100 and 120 pounds. And you don't just necessarily go moving them around willy-nilly. So managed to get a fairly straight one onto the cart. Got it to the checkout along with about 200 pounds of quick setting concrete in bags. And as I was checking out, I happened to say to the clerk, I said, boy, I'm not sure how I'm going to get this into the car. And he said, no problem. He said, I'll come out and give you a hand. And he did. And so that made the job fairly easy. But they're still heavy. Bear that in mind if you want to use one of those pipes. So here, I'm jumping ahead a little bit in this particular photograph, but I can give you a few tips if you're going to use treated posts like this as part of one of your antenna project. First of all, the chemicals they use to treat this are kind of nasty, so you probably want to wear some gloves. But if no other reason, because of the big slivers that can be in these are kind of rough cut along the edges. And you don't want to get one of those stuck into your hand. Anytime that you want to mount something or screw something into a big timber like this, you want to drill a pilot hole. If not, you're going to split the wood. In fact, the wood tends to split on its own just because it's so large and it's wet when you get it with the chemicals. Use stainless hardware. And around here, conventional wisdom says you want to bury it about 4 feet in the ground below frost line. So I dug a 4.5-foot hole. I put some gravel in the bottom. That's about as far as I could get with a hand post hole digger, and set it in there. You want to try to keep it plumb. Once you start using cement, you got one chance to get this thing straight. So I tied 2 levels on, one on each side face, and used that to keep the device plumb. And if you notice up on the top, it's hard to see, but there's a hook up here that I used for guy lines, just to set some temporary lines out to keep it from tipping over, and it's plumb. Now, I mentioned that I started with a 6x6 treated lumber 10-foot post, but actually it's 5.5 by 5.5, and I cut 1 foot off the top. So what you see here is 5 feet sticking out of the ground and 4 feet buried down in the ground. And I used that one piece. I'll show you just a second. I cut, again, 1 foot piece off the top, and I'm using that as part of the support structure. So brace it, and at that point, you mix up some, I just dumped the concrete in, put some water in, stirred it up, and kept doing that a little bit at a time until I had 200 pounds of concrete in this hole. Now, the next step, step number 2 in building it, is I needed a way to support the bottom of the post. And as I showed you earlier, the bottoms of these irrigation pipes can differ slightly in size. I know they're around 4 inches, but in this particular case, I built the support saddle out of aluminum. This is about 8 inches wide by about 4.5 inches deep. And it's set up in order to have a pivoting angle on these back bolts. And so this thing will open and close, I don't know if you can see it, and allow some adjustability for different diameter bottoms of pipe. Now, it's not hugely adjustable but you certainly could go to a little bit bigger pipe. And again, it was all done with stainless steel hardware. A little bit hard to see, but it's lag bolted with stainless steel lag bolts that are sitting on stainless fender washers. So the aluminum structure here is supported above the timber to keep the chemicals from reacting with the aluminum. And this was mounted on the 1 foot piece of cutoff post. And I'll show you that just in a second. It's here on the bottom, you can see it, but you'll see it better in another slide or two. So here's my post. I think at one time early in its life, somebody either used it decoratively or actually as a flagpole. And it had the little rope tie on it. Maybe this will be a clue to someone in the club. They can tell me where this thing came from. Down at the bottom of the post, you'll notice that it had been damaged and repaired by the former owner, who wrapped some aluminum sheet around it with some screws. As I mentioned, it's only 50 thousandths thick, so it's fairly springy. You can pick it up in the middle, and the ends will droop a little bit or bounce, but it'll support itself. It's still fairly strong. But I didn't want to put some kind of a crushing thing here to try to hold it. So I built some anti-crush support tubes. You can see them here laying in the bottom right of the picture. This is a 2 by 2 foot sheet of aluminum cut in half. So now I had 1 foot tall pieces of aluminum. I wrapped it around a hard form. I think I used some PVC 4-inch pipe and wrapped them into a circle and formed them. And these cylinders then are slid over the pipe, up the pipe to the top, and secured with stainless steel hose clamps. And I used 3 of them. So really, one of those spiral tubes is sitting on top of the other one. So I have a double thickness here. And the intent was both to distribute any loading and try to prevent from crushing this particular tube. When you look at the other side of it, the top side, I wanted to prepare the top of the mast. And at the top, I put 3 120-degree spaced loops. There was 1 loop here, 1 here, and 1 on the back that you can't see. There's a PVC pipe cap on the top. I wanted to keep water out of it as much as I could, maybe critters too, although I don't think that'll be a particular problem, but mostly water and rain. And I want to thank Stan for a suggestion. He told me on a net one night, and I didn't know this, that there are rattle can paints that are available for plastic. And I'd always used them to paint metal things, but he's absolutely right. You can go to the hardware store and get plastic spray paint. So I spray painted a PVC cap. The white PVC, as you probably know, is not very suitable for outdoor use because the UV light in the sun will ruin the pipe over time. So in this case, it's a white PVC pipe painted black, and it should have some more UV protection in here. The whole system was mounted with stainless hardware and nylon standoffs in order to give me some gap, but still to provide the function of keeping the water out of the pipe. So I used these 3 tie points up here for 2 of my antenna ropes. Remember, there's 2 antennas that are going to hang from here, the end-fed half wave and the fan dipole. And the other points I would use for a series of guy ropes that I was hoping to keep out of tripping distance and out of hanging distance. But the pipe by itself, I wouldn't necessarily trust it without some guy support. I think it would be okay in most cases. A pipe like this probably wouldn't be suitable to put much of a rotator or a beam antenna on, maybe a small one, but you'd have to be pretty careful. And I think you have to guy them at some point or you're going to risk kinking the pipe. So here's the whole system fit together. It's still laying on the ground, but what you can see here is my 1 foot piece of 6 by 6 lumber. It's already been pre-drilled on a drill press to keep the hole straight. This is the support saddle that goes on the top of the post. It's lag bolted on. And the pipe itself with the crush protector up here about 3 feet up. So everything seemed to fit. And the next step then was to mount the base to the vertical post. This again is the 5-foot post up in the top. And down here in the bottom, it's a little hard to see in this particular picture, but I moved this 1-foot piece of lumber 1 foot up off the ground. So it's not sitting on the ground. I ratchet tied it, used ratchet straps to hold it onto the post. So now I've got 2 of these sections of post held together for the purposes of drilling the hole through here and getting it perfectly aligned. The bolts are 12-inch long bolts, which fit fine because it's 11 inches of wood, and they're 1/2-inch galvanized steel bolts. Each piece of wood is 5.5 inches, so I had 1 inch left over for the bolting on the back. And I can tell you, this is kind of a tricky operation to do with hand tools, because when you try to drill a hole that long, it tends to go a little crooked on you if you don't pay attention. So it's nice to pre-drill this section first. And I had done that, and then I drilled a smaller pilot hole and then a larger hole through the entire system. At that point, you put the bolts on, you use stainless steel washers, and then you worry about how am I going to fasten the top of the mast to the top of the post. And in this case, the top clamp assembly is again a piece of angle aluminum. It's leg bolted onto the post. You can see here with a couple of stainless steel leg bolts that are sitting on top of stainless fender washers. So the idea again is to keep the aluminum away from the wood or isolate it with only stainless steel. The angle stock up here was drilled for a 4.5-inch U-bolt, 1/2-inch diameter U-bolt. And I can tell you, these aren't commonly available in most everyday hardware stores. I wanted stainless so it wouldn't rust. And one night on the net, I was chatting with K9MOI, and I said, boy, I don't know where I'm going to get a stainless steel U-bolt that big. And he goes, oh, I got them. So thanks to K9MOI for donating actually 2 stainless steel U-bolts. I only used one of them, Don, so I can get one back to you. But it was kind of a lifesaver because I wasn't quite sure where I was going to find a clamp, a U-bolt this big. It doesn't look that big in the photograph, but trust me, this is 1/2-inch stainless steel built into a U-bolt. So a beautiful structure at that point, I think. And here it is. My wife and I hoisted this thing. She sort of kept it from tipping over. We got it standing upright. It's a little awkward. It's not especially heavy. And we picked it up, put it into the saddle. And then if you look at the top section has this U-clamp around it to hold it on. And the whole system at this point, I don't have a photograph to show, but the aluminum pipe is even moved away from the post. So the aluminum pipe does not sit against this post. There's a gap in between here, controlled by the spacing of where these clamps are. So I think I accomplished my goal of having only stainless in contact with the treated wood. And the next step then, the final step, was to guy it. And I don't know if you've seen these or not. I just take the opportunity. I found these gadgets at HRO, the HRO store. They're kind of a luxury, but I've got a lot of antenna rope up. And I noticed in the section of HRO where they sell the rope, they've got these things called Buckmaster line grips. And they're a relatively simple device. If you take a look down in the center of the barrel here, you can see one of the 3 ball bearings that are down inside that. And those ball bearings are pushed into the nose of this gadget by a spring-loaded plunger in the back. So to load your rope, you pull the plunger back, the stainless or the ball bearings fall down, and you can slide the rope through. When you let the plunger go, the ball bearings are pushed up and pinch the rope. So it becomes a one-way traveling anchor for rope. It will resist being pulled out, but if you pull on the bottom, you can tension it. So it's a nice, easy way to tension any kind of a rope system that you've got. There's a little bit of a luxury in that you can do it by just tying the rope around a post if you want, but they work great, and I've been using them for a few years. Now, one thing I should change is I used rope. This goes to a fence post that holds my wife's garden fence up, and just because it's out of the way. But you really shouldn't use rope like this down at ground level, because if a grass fire comes through, it'll burn off your ropes. So conventional wisdom says you should use some steel lines, at least up a ways, to avoid a fire hazard, and then attach the rope. And that's something I should probably do in the future. So this is the way the mess looked. And I can tell you, trying to get all this up without having it tangled was a little bit of a chore. But there are 4 guy ropes and 2 antenna ropes. Here's one antenna going to the fan dipole. Here's another little rope going to the end-fed half wave. And the other ones go to various support structures that act as guy lines, none of which you can hang your chin on, I'm happy to say, at this point. So the first antenna to go back up was my fan dipole. For those of you who haven't seen something like this, again, there's parallel wires separated. In this case, they're only separated by about 2 inches. I make my own common mode chokes now. I put a common mode choke on this. It's not really necessary, but it's nice insurance. And one thing I wanted to mention, when you tape your coax connections on here, you should always start taping from the bottom and tape upward so that the tape overlaps itself like shingles overlap, and the water then tends to run down the outside rather than try to get inside. So I use 1 wrap of good electrical tape like Scotch 33. I then put a second wrap over of the linerness silicone tape that sticks to itself. It's waterproof. This tape isn't necessarily all that waterproof. So you can use a silicone tape over the top of this as a second wrap, and then a third wrap of electrical tape to protect the whole thing from UV light. Gets to be kind of a bundle, but hopefully it won't leak and won't corrode over time. The end-fed half wave went back up into a birch tree near my house. It had now started to snow when I took this picture, and so there's a transformer up here. It's a 49-to-1 end-fed transformer. The antenna wire goes out here. The coax cable kind of comes through a little strain relief down to the bottom, and this is the pulley system that holds this whole shebang up into the tree. My third antenna went up again. This, as I mentioned, is an end-fed half wave for 60, 30, and 15 meters, and it consists of a common mode choke down at the bottom, little counterpoise here, a short counterpoise, and the antenna transformer really starts here, goes 30 feet up in the air, and then 60 feet over. And it works fairly well. It's in kind of a crummy location because there's really 3 tree trunks here, and the center wire goes up through the middle of the tree trunks. So it works better than it probably should for me. Now, last section to talk about is how do you tension wire antennas like this? And I worked up a couple different things. The first thing I used was a 5-pound weight that consisted of a champagne bottle that I had emptied on New Year's Eve. I put this antenna up on like the 3rd of January. So I had a champagne bottle left over, filled it with some gravel, but it only ended up about 5 pounds, and it wasn't enough. I found these little hand barbells, and you can get them for a few dollars sometimes at the secondhand store. And it turns out that a 2-liter soda bottle will fit right over the top of one of these, and you can camouflage the soda bottle, drill and tap this for a 1/4-inch stainless steel bolt, and there you've got a 10-pound counterweight that's invisible to your neighbors. Maybe not. So that was the paint scheme. But the question is, well, is 10 pounds enough counterweight for an antenna like this? And I found that indeed, from a practical approach, I was happy. The whole idea here is you can pull the antenna wire tighter and tighter to take the sag out of the wire. But at some point, the wire breaks, and you don't have enough compliance in it for the wind to blow. And if you're using 3 trees, as I do or did in the past, I can guarantee you that on a windy day, those 3 trees will have a tendency to all be going in a different direction at once. So you need a fair amount of compliance. So just here for a quick example, as we're wrapping up, this wire was 132 feet long. It's very similar to the Davis RF 14 gauge plastic coated wire that I'm going to use on my next antenna. It has a nominal breaking strength of 115 pounds. You can find stronger wire, certainly, if you want, even in 14 gauge, but this is fairly flexible wire. So the question is, well, how hard should I tension that? And it goes back, if you ever looked at electrical lines, high voltage lines, you'll see a big sag from tower to tower. And that sag distance is controlled by how tight you pull the wire. Obviously, you can pull it harder and harder, but it puts more stress on everything. So the trick is to find the happy medium in the amount of stress. And if you check the ARRL antenna book, and I suspect many of you have an older one or even a newer one, you'll find either a nomograph or a simple equation for calculating the wire sag in a long wire. In this particular case, there's really only three variables that you have to worry about. You have to figure out what the weight of the wire is in pounds per foot. And that's on the data sheet for most antenna wire. And my particular one happened to be 15 pounds per 1,000 feet, or 0.015 pound for 1 foot of wire. You then say, well, how far do I want to span? In this case, about 132 feet. How much tension can I put on? Well, I have a 10-pound barbell. It goes down through a pulley system, but it's still just 10 pounds. So I have a 10-pound weight on my 132 feet wire, which weighs this amount. You plug that into the antenna book calculation, and really all you have to do is take the weight of the wire times the span, you square the span, and multiply it times 8 times the weight that you put on it. So in this case, 80 pounds. And it turns out that 10-foot barbell results in about a 3.3 foot sag on my long wire antenna, which I think I think that's okay. But if I increased it to 25 pounds of weight, of barbell weight, I could raise it up to only a 1.3 foot sag. I don't think I'm going to do that. But even at 25 pounds, I'm still well under the nominal tensile strength of the wire. So that's what I did. I did it by hand, and then I kind of calculated it afterwards and went, yeah, it looks about right. It's harder if you have a center fed dipole, because you've now got the center insulator and the feed line, the coax, pulling it all down, but it works fine for a long wire, and it's in your antenna book. One last thing, ran across this great article in the January 2020 QST, and it was done by WB4MIO, and he called this a gravity fuse. And he had wire antennas, and limbs of trees tend to fall on them. The trees tend to fall over time. And how much do you want to destroy when something like that happens? So in this particular case, he invented a weak link, if you will, and he used monofilament fishing line well below the breaking strength of the rest of his antenna system. And so I've gotten some 30-pound test line that seems that it might work okay with my 10-pound tension weight. And you can build a separable link here that will be a mechanical fuse that will break first before anything else breaks. In my case, I'm not so worried about the wire, but I have only one aluminum post, and I don't want to kink it if I can help it and ruin it. One trick, monofilament line is not very UV resistant, so you probably would want to put the monofilament line inside of like a heat shrink tube or something like that to keep the light off of it. It would probably last longer. And if a big wind comes along and breaks it, well, just make another one. You got 30, I got 25 or 250 yards of it in this case, so I can make a lot of these. And this is a project for the summer weather. So this is how the whole thing looks. Looking back from the roof of sort of my house, my neighbor is in the back, and I mentioned that I was trying to please my neighbor. I told him what I was doing. He was supportive. He was curious because he had seen one of the other wire antennas in the yard, wondered what it was. But I purposely put this post, where'd my pointer go? There's a cedar tree here, a small cedar tree, and I tried to put it in direct line with his family room spa area here. So if he looks out, he sees the tree and he doesn't see the bottom part of my post. He would if he looks up in the air, but I would have preferred to have the post out a little bit, but I purposely put it here to try to hide it from him. And he seemed appreciative of that. And at this point, he hasn't complained. Here's another view, my wife's garden, which is now in preparation for the spring season. So, quick summary. Wire antennas are inexpensive, They're relatively easy to build, common materials you can get in the hardware store, and they work well. They're a good way to start if you don't have a tower or the ability to put one up. Higher is always better with wire antennas, at least up to a point. And I've got a long ways to go to get one too high. At this point, I'm maybe at 35 feet in the middle because it's kind of a sloping antenna structure, actually. Trees are a lot cheaper than towers if you have trees. They can be your friend, although I found that they're often reluctant to cooperate, at least initially. And so the aluminum irrigation pipe works too if you can get one. Oh, piece of advice. If you're going to put up wire antennas with rope, always buy at least twice as much rope as you need. And I'm shocked in my short time as a ham. I've bought 1,500 feet of antenna rope, and where in the world it's all gone, I don't know. I think the trees maybe eat some of it. I have some left over, but you'll use a lot more rope than you ever thought you're going to when you start putting these things up. And the old corollary is always any antenna that's in the air always works better than one sitting in a box in your garage. So try to get one up in the air. We got great season now to do such things. Hopefully the rain's not going to be upon us. So at this point, I'd like to thank W9IPR and KC901OI. Both of the Toms were integral in my story here, as well as K9MOI, who helped with the clamp and actually just a lot of advice. Don's one of those guys that he probably has one of everything in his shop, and he has two of most things. And he's happy to share his experience with you. And lastly, my wife, who grudgingly tolerates my new hobby and helped me immeasurably on this particular project. So hopefully there was something here that might assist you with your next antenna, and I'll be happy to take any questions if there's any time left. Thank you.
Hey, Fred, this is Peter.
Hi, Peter.
So what kind of, do you use stranded or solid wire?
Both, actually. It turns out, well, I've used in the past what wire I had, and I tend to buy wire like that at swap meets. And so two of the antennas that you saw here are 12 gauge solid THHN house wire, just common number 12 house wire. People will say, well, solid copper wire stretches if you pull it. And it does if you pull it really tight, but I tend not to pull the particular antennas very tight. So two of the antennas are THHN 12 gauge, and the end-fed, the long wire, is 14 gauge stranded. It's more flexible.
I just had a comment, Fred. The way you connected that to the post is outstanding. Really smart idea. I really like the crush section over the pipe where the U-bolt is connected at the top. I thought that was a really good idea. Looks like it's really, really sturdy. Do you notice it moving much in the wind?
No, and I was curious because we've had some fairly windy weather, and the antennas bob up and down because they're not, I don't have really probably as much tension on them as I should. And back from a distance, I looked at that pipe and I couldn't see it move at all. I didn't walk up and sight up the length of the pipe. I'm sure that there was some movement. My guy lines are not in a perfect place. Two of them are tied to posts for my wife's garden. Another one goes back to that cedar tree that I showed there. So they're really not pulled in the exact right direction, but it seems to be good enough. Oh, I have a fourth one that goes to another tree off to the western edge of the property. But none of them are tripping hazards, but none of them are pulled in the right direction either. So I wouldn't want to do it without any guy lines on it, but I didn't see any movement at all, to be honest with you, Bill.
I suppose it helps too that the guy lines are right at the top and not like in the middle of the pipe, you know. The other thing I was going to mention, over the weekend, I was looking for some wire for field day. I want to make an off-center fed wire dipole for field day again. And I came across at Menards, they had something that they call trailer wire for wiring up trailers for cars. or any vehicles. And it's only 16 gauge, but it's got like a really heavy insulation on it, and it was $7.99 for 100 feet of it. So that's a pretty good deal. If you're looking for now 16 gauge is pretty small for a wire antenna. I wouldn't normally do that, but for field day, it'll be fine. It'll last for a few days anyway.
I haven't seen that. That sounds like a good buy. I remember reading something, you just keyed it up, that apparently there's some really cheap wire available that's actually aluminum wire with some kind of a copper coating on it. And I've never seen anything like that. You might, I guess, nip a little end of it off and take a look and see if it's actually solid copper strands, or if they're coated.
I actually wondered that exact same thing, because it was, a regular 100-foot spool of 14 gauge wire is like $28 right now. It's really expensive. And I wondered the same thing. I thought, well, this must be aluminum wire. So I looked on the spool and it didn't say anything, but I looked it up on Menard's website and it says copper wire. So whatever, aluminum wire would work fine for an antenna too, but
Yeah, and in fact, I built a 10-meter dipole using aluminum electric fence wire. And boy, if you're on a strict budget, it's a great solution. You can buy 250 feet of that for like $4 or $5, and it's a little tricky to terminate and work with, but it'll never rust. It might stretch, and it's used for electric fences. So that's an alternative as well. It's just not ideal to try to mate with a copper feed line of some kind, because you have the corrosion problem between copper and aluminum. But
where did you find that wire? Because they don't have it at Menard's.
Fleet Farm.
Okay, yeah.
In fact, you can buy it in rolls up to, I think, a half a mile long. I bought the smallest roll that I think that they had, and it was 250 feet. And last time I looked, it was still, I think it was under $5.
Let's hold the questions and the comments now till the session after the meeting. And first off, thank you very much, Fred. A very interesting presentation. And I can tell that you must have gone to a good engineering school, because that was a pretty well-planned and well thought out project. And I guess it hasn't fallen down. So that's always a good vote of confidence on the project too. But I think you did a really nice job, and I think a good job explaining it. And one of the things we can talk about after the meeting is sources of wire. And as you mentioned, Fleet Farm is an excellent place to buy large quantities of very cheap wire.